today we are going to look at solving some radical equations, and this is going to be part B of these notes. So we'll be doing some problems that are a little more difficult than we saw in the first section of these notes. If you are working on this on your remote days on Monday and Tuesday, these problems will not be on the midterm. So some of you will be working on these after the midterm. So the easier problems will be on the midterm. These more difficult ones will not be on the midterm. So let's look at an example here. So we've got our first example is going to be the square root of x plus 10 equals 5 minus the square root of 3 minus x. And so this is different than the problems that we've seen so far because we have two square roots in this particular problem. And we can't combine those square roots. We also have a number outside of the square root. So you might be tempted to, let me lock this in place so it doesn't go away. Don't write this down. This is going to be wrong. So you might be tempted to just do this. Say you're going to square both sides and say this is x plus 10 equals 25 minus 3 minus x. This is incorrect. You cannot do that. And the reason that you cannot do that is because whenever we are going to square both sides. We are going to do this. But whenever you square this right-hand side, you're really doing 5 minus the square root of 3 minus x times 5 minus the square root of 3 minus x. So you're going to have to distribute over here for this problem. On the left-hand side, it is just as simple as squaring this side. So you've got x plus 10 equals, but over here, we've got to square this side by distributing. So we've got to do 5 times 5, which is 25. And then we'll have 5 times negative square root of 3 minus x, which will give us minus 5 square root of 3 minus x. The middle term is also going to give us minus 5 square root of 3 minus x. And then for our last terms, we've got the square root of 3 minus x times the square root of 3 minus x. Whenever we multiply square root by itself, it's like squaring it, so that square and square root undo each other. So you're going to end up with minus parentheses, don't forget your parentheses right here, 3 minus x. I'm sorry, we will not have a minus right here. I'll have a plus because negative times negative will give us positive there. So if we simplify this a little bit further, we would have 25. These two things right here in the middle, these are like terms because that square root part is the same for both of these, so you can combine those. So negative 5 minus 5 would give you negative 10 square root of 3 minus x. And then you'd have plus 3 minus x. You can combine your like terms. You've got a 3 right here and a 25 that you could combine. So I'm going to have 28. I'm going to put this minus x up here, minus 10 square root of 3 minus x. So you've got to do all of that work just to square this right-hand side. So we've got that 28 minus x minus 10 square root of 3 minus x. So that's a lot of work just to square that side. Plus, we still have a square root in the problem. These problems are going to be pretty lengthy. I love doing these problems because it feels so good when you get to the answer at the end. But they are not easy problems. You're going to have, there's lots of steps. You have to be very perseverant whenever you're doing these problems. So here we have this set up. Now our next step is we want to get this square root right here by itself. So we're trying to isolate the square root. These problems, they get worse before they get better because you've got to get this square root right here by itself, and we're going to have to square both sides once again. So to do that, I could subtract this 28 like this. I could also add this x right here, so that gives me 2 4x minus 18 equals negative 10 square root of 3 minus x. Now, I need to get rid of this negative 10. Here's the problem. 2 and 18, neither one of those are divisible by 10. So if I divide by negative 10 here, I'm going to get fractions over here on this left-hand side, which I can do and I can deal with, but I've got to deal with those fractions, which I'm not crazy about. So rather than moving this negative 10, I'm going to go ahead and square both sides here. So I'm squaring both sides. Now, on the left-hand side, that means you've got 2x minus 18 squared here, so you can square, double square. So you'll have 4x squared minus 2 times 18 is going to give you 36. And whenever you multiply that by 2, you'll get 72x. And then 18 squared is 324, so plus 324. If you need to, you can go over to the side, 2x minus 18 times 2x minus 18, and you can distribute like that. This is the answer you're going to get whenever you do that. Now, over here on the right-hand side, negative 10 is multiplied by the square root of 3 minus x. So since these two things are multiplied, we can square them separately. Now, up here, we could not. So when we had 5 minus the square root of 3 minus x, we could not square the 5 and the square root separately. We had to FOIL that out. We had to write this over here. But right here, these two values are multiplied, so we can square them separately. So if I square negative 10, I get 100. And if I square the square root of 3 minus x, I just get 3 minus x. Make sure you keep that in parentheses there. So now, it's still looking pretty bad. I've got huge numbers, but I am down to a quadratic here, and all of my square roots are gone. So I'm going to distribute my 100 here, so 4x squared minus 72x plus 324 is going to equal 300 minus 100x. And so I'm going to continue on here by moving everything to one side, because when I have a quadratic, I want to move everything to one side. So I'm going to add 100x here to move that 100x to the left side. I'm also going to subtract my 300 to move my 300 to the left-hand side. So I will get 4x squared plus 28x plus 24 equals 0. And I can see here I've got 4, 28, and 24. All of those numbers are divisible by 4. So I'm going to divide off that 4 here just to have a little bit smaller numbers to deal with. So x squared plus 7x plus 6 equals 0. And conveniently, whenever I do that, I've got something that I can factor. You could use quadratic formula, but this will factor. So if we factor this, we've got x, and then we could do a plus 6 and a plus 1, and that would give us 0. And so we're going to get two solutions here. We're going to get x equals negative 6 and x equals negative 1. Now, as we did with our other problems, we must check for extraneous solutions. With square root problems, they are very, very, very common. So we may have an extraneous solution. We've got to go back to the original problem and check. So that original problem was the square root of x plus 10 equals 5 minus the square root of 3 minus x. So we've got to check to see if these numbers work. So if I plug in negative 6, I get the square root of negative 6 plus 10 equals 5 minus the square root of 3 minus negative 6. And this is going to be the square root of 4 equals 5 minus the square root of 9. So we get 2 equals 5 minus 3. And of course, 2 does equal 5 minus 3. So negative 6 is one of my answers. I also need to check negative 1. So if I plug in -1, I've got -1 plus 10 equals 5 minus the square root of 3 minus -1 here. And if I check that, I've got here the square root of 9 equals 5 minus the square root of 4. And that is going to give me 3 equals 5 minus 2. And of course 3 does equal 5 minus 2. So you do have two answers for this. This particular problem did not have an extraneous solution, but you need to check every time. Okay, let's do a second example here. So let's look at this problem here. So for example 2, we're going to do the square root of a plus 21 minus 1 equals the square root of a plus 12. And whenever we do these problems here, these problems are going to be the ones that are the most difficult. It's where we've got two square roots and also a number on the outside of the square root. So whenever you see these problems, you need to be prepared for a problem that's going to take you a little while to do. So like the last problem, we're going to square both sides. And over here on this left-hand side, this is where things get complicated because you've got to do the square root of a plus 21 minus 1 times the square root of a plus 21 minus 1. And over here on the right-hand side, it's very simple. It's just a plus 12 because everything's under the square root here, so the square and the square root cancel each other out. So we're going to distribute here. Square root of a plus 21 times square root of a plus 21 is just a plus 21. And then we will multiply square root of a plus 21 times this -1, which will give us negative, I'm going to put the 1 here, -1 square root of a plus 21. You don't need this here, but it helps some students see what we do when we're combining here, so I'm going to leave it. We'll have another -1 times the square root of a plus 21, and then -1 times -1 is +1. And this all equals a plus 12. And so now we can combine any like terms. So I could put my 21 and my 1 together. I also can combine my -1 square root of a plus 21s. And so when I do that, this a, it's going to stay out front. 21 and 1 is going to give us 22. And then I've got a -1 square root of a plus 21, another -1 plus square root of a plus 21, which is going to give us -2 square root of a plus 21. And this all equals a plus 12. So to solve this problem now, we've combined all that we can. We want to now focus on getting this square root right here by itself so that we can square both sides here. So I'm going to subtract the a, and this problem is actually going to end up being a little bit easier than the last problem because the a's cancel on both sides. So that's going to make our life a little bit easier. And then we're going to subtract 22. And so we've got -2 square root of a plus 21 equals, and then 12 minus 22 is going to give us -10. And in this case, I can go ahead and divide off that -2 because 10 is divisible by -2. And we are going to get square root of a plus 21 equals 5. And this one is so much easier than the other problem because we don't have any variables left here on the right side. So we can just square both sides of this equation, and we get a plus 21 equals 25. And we're going to subtract 21 from both sides, and so a will equal 4. Of course, with these problems, we always have to go back up here and check to see if it works. We're always checking for extraneous solutions. So we've got to do 4 plus 21 minus 1 equals the square root of 4 plus 12. And so this is going to give us the square root of 25 minus 1 equals the square root of 16. Square root of 25 is 5. 5 minus 1 equals the square root of 16, which is 4. 5 minus 1 does equal 4. So we know that our answer here is correct. This is not an extraneous solution. All right, let's do another one of these. So for example 3, we are going to have this problem here. The square root of x plus 2. No, I'm sorry. That's wrong problem. Let's not do that one. We're going to do the square root of 2x plus 1 plus the square root of 2x plus 6 equals 5. So let's think about this problem a little bit here. This is going to be a difficult problem. We've got 2 square roots. We've got something else over here that's not underneath the square root. So we can't just square both sides and get rid of the square root. This particular problem is going to be especially difficult because over here on the left-hand side, if we square this, we've got square roots in both of the terms. And that makes this problem a little bit difficult to solve. So what I would suggest doing is don't deal with the square roots on both sides. What you can do is you can just move one of these square roots over to the other side. And it doesn't matter which one you choose. I think I'm going to take this one. I'm going to subtract this square root of 2x plus 6, square root of 2x plus 6. So I'm just taking this right here and moving it to the other side. And that is going to give me the square root of 2x plus 1 equals 5 minus the square root of 2x plus 6. This just helps you avoid having to square something that has 2 square roots in it, because that can become very difficult to do. So at this point, it looks like the last problem that we did. So we're just going to square both sides of our equation here. And we're going to get 2x plus 1. But over here on the right-hand side, that is our difficult side. So 2x plus 6. And then 5 minus the square root of 2x plus 6. We're going to have to distribute here. So 5 times 5 is 25. We'll have minus 5 square root of 2x plus 6. And then the middle terms will also get the minus 5 square root of 2x plus 6. And then the last terms will get plus 2x plus 6, because that negative times negative will give us a positive there. And so we can look for like terms that we can combine. So this 25 and this 6, we can put those together. We can also combine our square root of 2x plus 6's here. So we're going to get 2x plus 1 equals, I'm going to go ahead and write this 2x up front. And then 25 and 6 is going to give us 31. And then we're going to have minus 10 square root of 2x plus 6. And so this problem is like the one that we just did. It's just a little bit easier than that first problem that we did, because when I subtract this 2x right here to move it to the other side, the x's cancel on both sides. So then I can subtract my 31, and I get negative 30 equals negative 10 square root of 2x plus 6. And now I'm down to a much more simple equation, so I'm just going to divide both sides by negative 10, and I'm going to get 3 equals the square root of 2x plus 6. I can square both sides here, and I'm going to get 9 equals 2x plus 6. And now just a simple two-step equation. So we subtract our 6, 3 equals 2x. Divide by 2, we're going to get x equals 3 over 2. Again, you have to check your answers on these. So 3 over 2 is probably our answer, especially since it's the only one we got, but we've got to check our answer. So we're going to go all the way back up here to our original problem. And so we're going to say 2 times 3 over 2 plus 1 plus square root of 2 times 3 over 2 plus 6 equals 5. And so we've got the 2's will cancel right here, and we'll have the square root of 3 plus 1. And then right here, we'll get the square root of 3 plus 6 equals 5. So we have the square root of 4 plus the square root of 9 equals 5. Square root of 4, of course, is 2. Square root of 9 is 3. And that does equal 5. So we know that this is our correct answer. X does equal 3/2. Alright, let's do another one that is going to be a little bit more difficult. And this will be a little bit more like the first problem that we did. We've got the square root of 3x plus 10 equals the square root of x plus 11 minus 1. And so we're going to square both sides here. And whenever we do that, we're going to get on the left-hand side 3x plus 10. On the right-hand side, we've got to write this twice. Square root of x plus 11 minus 1 times the square root of x plus 11 minus 1. And we are going to distribute here. So square root of x plus 11 times the square root of x plus 11 just equals x plus 11. The square root of x plus 11 times negative 1 is going to give us negative 1 square root of x plus 11. This middle term here will also give us negative 1 times the square root of x plus 11. And then our last terms, negative 1 times negative 1 is positive 1. And then over here, we've still got that 3x plus 10. We want to combine our like terms before we go any further. So we've got 3x plus 10 equals, and so I can put this 1 and this 11 together, so I'll get x plus 12 minus 2 square root of x plus 11. And now I can move my other terms over to the other side. So I'm going to subtract that x and subtract that 12. And so that gives me 2x minus 2 equals negative 2 times the square root of x plus 11. Now, for this particular problem, on the first problem we did, I could not get rid of that negative 2 because it wouldn't divide evenly. But on this problem, if I divide the right-hand side and the left-hand side by negative 2, it's going to go nice and evenly. So that's going to give me negative x plus 1 equals the square root of x plus 11. Now, this problem is a more difficult problem because you still have a square root left. So, and an x left over here on the side. So you're going to have to square both sides again. And when you do that, remember your square, double square for this. So you're going to get x squared minus 2x plus 1 here. And over on the right-hand side, just x plus 11. You need to move everything to one side because you've got a quadratic here. So you're going to subtract x from both sides and subtract 11 from both sides. So you can move those terms from the right to the left. And we'll have x squared minus 3x minus 10 equals 0. Fortunately, this will factor. So we've got... we're going to have x minus 5 and x plus 2 is how this one will factor, which gives us two answers, x equals 5 and x equals negative 2. Now, you're almost finished, but you must check for extraneous solutions because sometimes whenever you're solving square root equations, in fact, pretty often when you're solving square root equations, you're going to get extraneous solutions. So 5 and negative 2, we've got to go back up here to the top and we've got to check them. So we've got the square root of 3 times 5 plus 10 equals the square root of 5 plus 11 minus 1. And so this is going to be the square root of 15 plus 10, which of course is the square root of 25. And over here we've got the square root of 16 minus 1, which of course is 4 minus 1. So 5 equals 4 minus 1. Now, this is not correct. 4 minus 1 equals 3. 5 does not equal 3. So this tells us that 5 is an extraneous solution. So we're going to throw that one out. Hopefully negative 2 is going to be a solution for us. It's abnormal for both of these to be extraneous. Most of the time, if they're both extraneous, it probably means that you made a mistake solving the problem. Hopefully we did not do that. So let's check -2 and hope that it works. So this is going to give us the square root of -6 plus 10 equals the square root of 9 minus 1. Square root of 4 equals 3 minus 1. So 2 equals 3 minus 1 is 2. This answer does work. So -2 is our only answer since 5 was extraneous. All right, I want us to look at one more problem here. And this is going to be our last example, and it's going to be possibly, in ways, our most difficult, in ways not. It's certainly one of the most frightening because of all the square roots. So we've got square root of k plus 9 minus the square root of k equals the square root of 3. And so this one at first glance is, like I said, probably the most difficult problem that we've had because we've got so many square roots. You've got 3 separate square roots in this problem. However, we can solve this much like we've done the other problems. Now, first of all, here I've got just square root of k, and here I've got square root of 3, and those are much smaller than my square root of k plus 9. So it is going to make this problem just a little bit easier if I move this square root of k over to the other side, which is going to give me square root of k plus 9 equals the square root of 3 plus the square root of k. Now, I still have a lot of square roots, but it's a little bit easier to square this on the right-hand side than it would be to square the left-hand side of the original problem. So, if we square the left-hand side of what we've got here, we'll have k plus 9. On the right-hand side, we've got square root of 3 plus square root of k times the square root of 3 plus square root of k. And we have to distribute here. So square root of 3 times square root of 3 is 9. And square root of 3 times square root of k. Now both of these are underneath the square root. So this is going to give us the square root of 3k. And when we multiply the middle terms here, we're going to get another square root of 3k. And then square root of k times square root of k is k squared. Now, it may even help you here if you write yourself a 1 on the outside of these square root of 3k's, because when we combine them, we're not multiplying square root of 3k times square root of 3k, we're adding these two together. So we've got 1 square root of 3k and another 1 square root of 3k, so that is going to give us 2 square root of 3k here. So we'll have k plus 9 equals 9 plus 2 square root of 3k plus k squared. And what we need to do now is we need to move everything away from this square root because we're going to have to square both sides again. So I could subtract this 9 right here, which actually is going to cancel on both sides. I also could subtract my k squared. And so on this left-hand side, I've got k minus k squared equals 2 times the square root of 3k. So for this particular problem, I've got this 2 right here, which I really would like to divide off, but k and k squared are not divisible by 2. So instead, I'm just going to leave it where it's at, and I'm going to square both sides like we did on that first problem. And here, I've got k minus k squared times k minus k squared. We've got a square, double square there, but I'm going to write it out just because that's a little different than we normally deal with. And then over here, these two things are multiplied, so I can just square them separately. So 2 squared is 4, and the square root of 3k squared is just 3k. And so over here, I'm going to have k times k, which is k squared. Then k times k squared, which is going to be negative k to the third. And then in the middle here, I'll get another negative k to the third. And then here, I'll get a positive k to the fourth. And that's going to equal 12k. Then, if we continue on, I'm going to combine my like terms over here. I'm also going to put this k to the fourth first. Then I've got a negative, you could think of this as a negative 1k to the third and another negative 1k to the third, which is going to give you negative 2k to the third when you combine those. And then plus k squared equals 12k. And then I need to move this 12k over here to the other side. So I've got k to the fourth minus 2k to the third plus k squared minus 12k equals 0. And this is a problem because we've got 4 terms here. Now, I do see that I have a k with every term, so I'm going to factor out a k. And that's going to leave me with k to the third minus 2k squared plus k minus 12 equals 0. And so I know k will equal 0. I also know k to the third minus 2k squared plus k minus 12 has to equal 0. Now, our textbook would have us learn how to solve that. However, we have not done that in this class. Now, with Coach Wood, with your P, or Mr. Brown, with your P's and K's and your synthetic division, you could have found that if you guys did that this year. But we're not going to go into that. We instead are going to use Desmos to solve this part. So if you get anything that has a k to the third or higher, let's just go to Desmos to solve that. So if I go to Desmos here, and I type in k to the third, or let's use x for Desmos, y equals x to the third minus 2x squared plus x minus 12. We're going to get this equation here, and you can see there's just one place where it crosses the x-axis, where it's y is 0. So this is where this value equals 0. So you're looking for that x-intercept, and we get 3 for this. So k equals 3 is the answer that we get. So again, I don't think you're going to have many problems where this happens, but if you get something where you have a k to the third power, you can just go, or fourth power, fifth power, sixth power, go to Desmos, type the equation in like it is a function, y equals, and then put the equation, and then see where your x-intercept is at. That is where your equation will equal 0. Now, we do have to go back and check to see if these answers are correct. So, we've got to go back and we've got to try 0. So we've got square root of 0 plus 9 minus the square root of 0 equals the square root of 3. And so 0 plus 9 is 9, so we've got square root of 9 minus 0 equals square root of 3. Of course, square root of 9 is 3. That 3 is no longer underneath the square root, so 3 does not equal the square root of 3. So 0 is an extraneous solution. We do not include 0 as an answer. We also want to check 3. So if we do the square root of 3 plus 9 minus the square root of 3, that's going to equal the square root of 3. And so square root of 3 plus 9 is the square root of 12 minus the square root of 3, which is supposed to equal the square root of 3. So this one's a little bit strange, but 12 will break down. We could break 12 down into 4 times 3, which means this is going to give us 2 square root of 3 minus, I'm going to put a 1 right here in front of this. So 1 square root of 3 equals the square root of 3. And then 2 square root of 3 minus 1 square root of 3 just gives you 1 square root of 3, or just square root of 3 itself, which does equal square root of 3. So 3 is a correct answer. If it's throwing you off a little bit here dealing with this, you could always go over to the calculator again So if you go over here to the calculator and you type it in, if you've got square root of 12 minus the square root of 3, it's going to give you this value. If you just type in square root of 3, it gives you that same value, so you know that this is correct. So k equals 3 would be our answer for this problem.